Hi class, we are starting 10B now. Yay. All right, so 10B, we are problem solving with geometry. So the geometry that we dealt with in 10A, we're using that and a few more geometric formulas and ideas in order to solve a few more problems. We're going to look at quite a few crazy things during 10B. I hope you enjoy it. All right, first thing we're going to talk about is measuring angles. As we know, our Earth is a circle. Well, it's a sphere. So because it's a sphere, we're having to deal with angles a lot, and we will be using angles or working with angles in our navigation and architectural design. Everything that we have or that we measure on our Earth has to be in a circle or in degrees because we're moving around the edge of the Earth or the circumference of the Earth. So if we're measuring the steepness of mountains and the orientation of roads and for the characterizing of triangles, we're dealing with angles all the time. So sometimes we need a greater precision for many geometrical problems, such as 1 degree doesn't quite cut it. If we're navigating, if we're driving a boat across the ocean from America to England, which we can't do right now, but eventually we can, if we're driving that boat around, then it might be that we go for 40 miles one direction, and then we have to change our angle or our degree and travel another 40 miles. It's not that we're going to change exactly 5 degrees. We might have to change 5.569 degrees. It's not going to be an exact 5-degree measure change. So we have to be as precise as we can. If you're looking at this little picture here, we have the full circle is 360 degrees. Now, if we take one of those degrees and we break it up, then we can break it up into actual minutes. So there will be 60 minutes. So we can have a 20-degree minute, no degrees, just 20 minutes, or 40 minutes, or 52 minutes. But we can break up a degree into minutes, up to 60 minutes. And then each of those 60 minutes breaks into 60 seconds. You see the two little apostrophes there. That means seconds. So 1 degree breaks down to 60 minutes, and then each of the 60 minutes break down to 60 seconds. So each degree is subdivided, and then each minute is subdivided. All right, and that's what we deal with degrees. Now, we can convert. Now, I'm not going to show you the multiplication way of converting because we have these handy-dandy calculators that we're going to use. So I'm going to go to my image. Right here, we're going to look at my calculator, and I'm going to show you how to convert using the calculator. So if we're trying to convert 3.6 degrees into the degrees, minutes, and seconds, those degrees, minutes, and seconds are actually programmed in your calculator, which is really, really nice. So where that you find them is in your angle menu. So let's kind of zoom out a little, zoom out a little bit so that you can better see my calculator. And you see right here in blue, it says angle. It's not very, let's see. You see angle there. In that menu, if you go into the angle menu, you see degrees and then minutes, you have R, you have DMS. Now that's your conversion that we're going to use. If you want to convert a decimal degree, they call this 3.6 decimal degrees into DMS, degrees, minutes, seconds, then you're going to use this 4 option DMS. Now, if you're using the yellow calculator here, you also have an angle menu. It's right there. So if I was in here, I would do second angle in order to get our degrees, minutes, seconds. And if you go down, if this goes down, you're going to see number 6 DMS. So that's where you find it. So if I'm converting degrees, minutes, seconds, then I'm going to type in 3.6 first. So let me get out of that. So 3.6, and that's degrees, and I want to convert to DMS. So I'm going to go into my angle menu, so second angle, and then I'm going to go down to 4 to my DMS and hit enter and see how it gives you the 3.6 into DMS, and you say enter again. Yep, that's what I want, and that's what it is. It's 3 degrees, so that is a little more than half of 3 degrees, right? So it's between 3 and 4 degrees. So that's what you would expect your conversion to go because you're just breaking down that 0.6 into how many minutes and seconds. And in this case, you have 3 degrees, 36 minutes, and 0 seconds. Okay? So that breaks it down into DMS. We'll try another one. So we're trying to convert 191.37 degrees into DMS form. Notice how it's degrees, minutes, seconds. So 191, we'll type that in first, 0.37, and then we'll go to our angle menu and hit 4 for DMS form. And yep, that's what we want to do. So we hit enter, and that's 191 degrees, 22 minutes, and 12 seconds. Now, this is already in DMS form, and we want to go back to the decimal form. In order to do that, what you'll do is you'll type this all in as you see it. So you're going to do 30, then degrees, then 33, then minutes, and then 31, then seconds. And then you're going to hit enter, and it will change it to its decimal form. So you'll type in 30, and you saw the degree in the angle menu. So we'll go back to the angle menu and hit 1 and put a degree there. And then 33 minutes, go back to the angle and hit 2, and that will put a minute there, and then 31. Now, seconds isn't in the DMS menu in this calculator. If you have the yellow one, it's there. You'll have your seconds. You can see it. I'm not sure where that went, but at the second menu, oh, we're almost there. Oh, so if you go into your angle menu, it's right there, number 2. So, I can't put seconds here though. Seconds is above, you see it right here, it's green, and it's above the plus sign, but you have to hit alpha and then plus, and that's where your seconds are, right there. Hard to find. And then you hit enter, and you have your 33.559, and I don't know how far you want to go with your decimal, but usually they do about 30.559 degrees, and that will be your decimal form. And that's that. So that's pretty exciting, right? And they're very easy. You just have to use your calculator and then go. Simple. All right, so we're going to move on to longitude and latitude. Latitude and longitude, I should say it that way. So we can locate any place on the Earth's surface by its latitude. That latitude, you're going to notice right here, line of latitude. And that's north or south position from the equator. So you have your equator and your latitude, you move one, that's the line of latitude, that's 30 degrees north. If you move another 30 degrees north, you find another line of latitude, and then here's your equator. If you go 30 degrees south, so south of that equator, are going to have a little south on the end of them. North of the equator, you're going to have a little north on the end of them. So, and these, of course, there are lines going all the way across. You're only seeing the ones at 30 degrees and 60 degrees. And as you notice, as you go up there, what's right there? That's your North Pole, and it's 90 degrees, right? So that's why they moved up and drew in the latitude lines that are every 30 degrees, because you can only go as far north as 90 degrees. You can only go as far south as 90 degrees. And then your east-west position are going to be your longitude lines, and your longitude lines go very long. That's how I remember that they're long. All right, they go from pole to pole. And again, they've marked each of these every 30 degrees as well. Right here is the prime meridian, and the prime meridian is at longitude 0 degrees. So, and then if you move this way 30 degrees, you have 30 degrees west, and you're moving westward 30 degrees. All the way up, you can go west until 180 degrees. So directly opposite the Earth over here is 180 degrees longitude, and you can go on the east side as well. So anyway, any point, you notice every little point here. You have Greenwich right here. You have Rome right here. By the way, Greenwich, you'll note, is right on the prime meridian. So it's right on that divider. And stating any latitude and longitude pinpoints just gives you a location on the Earth. And I've seen it on my GPS system. If I've hit a little pin, sometimes it just gives the longitude and latitude of where I'm going. But that's where you find it, is right in there. So latitude measures positions north or south of the equator. It's defined to have latitude of 0 degrees. And then locations in the northern hemisphere have latitudes denoted with an N, and locations in the southern hemisphere have latitudes denoted with an S. The North Pole has latitude of 90 degrees north, and the South Pole has latitude of 90 degrees south. Lines of latitude are actually circles running parallel to the equator. Now, longitude measures east-west position, and semicircles extending from the North Pole, so you got up to the North Pole, and then all the way down to the South Pole. And the line of latitude passing through Greenwich, England, is defined to be longitude 0 degrees, and it's also called the prime meridian. Longitudes are usually given with an angle less than or equal to 180 degrees, and locations less than halfway around the world to the east of the prime meridian has a longitude designation of E, and then a location to the west has a longitude designation of W. So that's just basic information about latitude and longitude. We're going to do a few questions here. And again, I like to go back to my notes so that I can answer them more easily and at least write in. So suppose you could drill from Miami straight through the center of the Earth and continue in a straight line to the other side of the Earth. At what latitude and longitude would you emerge? And actually, I want to show you on the computer back here so you can see what's happening. So let's go back. And I'll just read it from my notes here. So when you're looking at that picture, suppose you're at Miami. In Miami, you have right here. That's where Miami is. Okay, so if you're drilling from Miami straight through the center of the Earth at a straight line, 180-degree line, and you continue to the other side of the Earth, what's going to happen on the other side of the Earth is that latitude, all right, the latitude, you're going to pop out the same distance from the equator on the other end, the same distance, but on the other side of the equator. So if Miami is latitude of 26 degrees north, when you pop out on the other side of the Earth, you're going to be at the same 26 degrees, but south of the equator. So that's dealing with the latitude. We also have to deal with the longitude. The longitude is going to be, you're going to go straight through, you're going to travel that 180 degrees to the changing point, and then you're going to go a little bit more. So basically you're going to be heading on the east. You're going to, if you start at the west, like in Miami is 80 degrees west, you're going to end up east on the east side because all the wests are here. You're going to end up on the other side where the easts are, and your east will be whatever the difference of 180 and 80 is, so 100 degrees east. Now that is crazy. So again, your latitude, 26 degrees north, you'll end up straight across, only south, the same distance that you were from the equator in Miami, but you'll be 26 degrees south, and then with your longitude, because you're on the other side, you're hitting the longitudes that are east, and it'll be 180 degrees directly on the other side. So 180 minus 80, the difference is going to be 80 degrees east. All right, so that would be your answer there, and I'm going to go back. Let's see, I'm going to actually write it down because I don't have to I don't have to remember those numbers. It's 100 degrees when I subtract them east. All right, so going back to our little notes here, you would end up at 26 degrees south, so the same distance where Miami was here, 26 degrees, it's going to be 26 degrees south. And then it's going to be 180 degrees around, so on the eastern side, 180 minus the 80. All right, and that gives you 100 degrees east. That is all my time for right now. This is going to be an incredibly long lesson. I might even have 3 parts, but I'm going to stop and then I'm going to move on again with the rest in part 2, so it uploads in a great way, right? Like those uploads to happen quickly.